Okay. All right, gentlemen, ladies. When we left off, we gave you guys some visual intuition on why we complete the square, right? And what that looks like and why we do what we do. Okay? We're going to use the same process with the generic quadratic function. Okay? We're going to complete the square to solve for x. And we're going to see what we get. Okay? So, I would pay attention because this will be on a quiz and or test. Okay? So, the first thing we want to do when we have a quadratic function is we want to get this c over to the other side. So we're going to subtract c from both sides. So I get ax squared plus bx equals, and actually, equals negative c. Okay? What I also want to do at this point is I want to make my quadratic equation over here, I want to make it monic. Who remembers what monic means? Not x equals 1. I want to get the coefficient in front of the x squared equal to 1. Okay, so I want my leading coefficient to be 1. That's what it means for a polynomial to be monic. Okay, so I'm going to factor out an a from this remaining expression. So then, if I factor out an a, what am I left with inside my parentheses? X squared. And then what, a times what gets me bx? Go ahead, what was that? bx over a. Except I'm going to leave my coefficient separate from my x variable, okay? So it's b over a times x. So I wrote the same thing the Mason just said, it just looks a little different, right? And then I'm going to leave a gap equals negative c. Okay, this is to complete the square part, right? What's half of b over a? Very good. b over 2a. b over 2a is my half of the middle term coefficient. Now I square that. When I square b over 2a, what do I get? Very close, 4a squared. And that's what I add. I add b squared over 4a squared. If I add it to this side, right, I also must add it to the other side. So, do I add b squared over 4a squared? Is that what I add? What do you think, Kristen? Is that what I add? I'm trying to trick you right now, right? What's the trick? I got to distribute the a. I'm really not adding b squared over 4a squared to this side. I'm adding b squared over 4a squared times a to this side, which means this squared over here goes away, right? You guys see that? So this is what I add. Okay? Good catch, Kristen. Okay. Now, this guy that I'm outlining in red, that's a perfect square polynomial, is it not? What is the perfect square polynomial? X plus b over 2a plus a squared, right? All times a. And that equals negative c plus b squared over 4a. Okay? I'm going to take this, now like negative c plus b squared over 4a. So I'm going to switch the order around, right? Because addition is commutative. Is that right, Logan? What does it mean to be commutative? I can switch the order around, right? So I'm going to do that. So I'm going to have b squared over 4a plus a negative c. And what's an easier way to write plus a negative c? Minus c. So that's going to be minus c. Can I get this over one fraction? This is over 1. Can I add those right now or subtract those right now? No. What do I have to do? I got to get a common denominator. What do I multiply? What's going to be my common denominator? What do you think, Caleb? Alex? 4a? Okay, so what do I have to multiply this guy by to get that common denominator? 4a over 4a. So what do I get over here? I get b squared over 4a minus 4ac over 4a. Now I can write it over one fraction, right? Let's do that. I'm going to put this over here so I don't lose track of it. Scroll down. So now it's equal to b squared minus 4ac over 4a. What's my next step? Okay. It's starting to look familiar, isn't it? What's my next step? Do I want this guy right here? How do I get rid of him? Divide. Divide both sides by that a, right? So if I divide this side by a, that goes away, right? That's also taking this and multiplying by 1 over a. Multiplying by the reciprocal is the same as dividing, right, Logan? Okay, so then I get x plus b over 2a quantity squared equals that. Let's write it again. X plus b over 2a quantity squared equals, and let's do this multiplication. So I got b squared minus 4ac over what? 4a squared, right? Now what? Square root. Both sides, right? Starting to look familiar, ladies and gentlemen? So, what's the square root of a squared term? Just a term, right? So x plus b over 2a equals, can I take the square root of this hot garbage? No, so let's just keep that in a bracket, right? What did I forget? Plus or minus, and this, what's the square root of the bottom? 2a. Now what? Subtract b over 2a from both sides. negative b over 2a, right? Plus or minus b squared minus 4ac over 2a. Actually, that. Can I combine those fractions? Do I have common denominators? I can put it under one fraction, right? So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Really? Now you know why we complete the square? This gives us a universal way to solve for the zeros of a quadratic function written in standard form, does it not? And I did it by completing the square. Get good at this, ladies and gentlemen. Get good at this. This is huge. This is huge. You can do this. You can do a lot. Okay? QED. It's Latin. Does it mean, James? Quad era demonstratum. It basically means from this I get that. And that's what math geeks always put at the end of their proofs or derivations. I just derived the quadratic formula. You need to be able to do the same. Practice set. Due on Tuesday. Tuesday? So what's going to happen if I make it due on Wednesday? How many people are going to do it Tuesday night if I make it due on Wednesday? No. Who are you kidding? You're not going to do it at all. Do Tuesday. Do Tuesday. All right? Additionally, all right, the rest of the day, work day.